Ever wondered what monoclonal antibodies are? Well, before we dive into that, let's first understand what antibodies are. Picture antibodies as the body's vigilant security guards, always on the lookout for trouble. They're elements of our immune system produced by cells known as B lymphocytes. Their primary task? To identify and bind to foreign proteins in our body called antigens. It's like a lock and key system where each antibody fits perfectly with its specific antigen. Once they latch onto these antigens, they eliminate them using various immune mechanisms. It's a fascinating process, like a microscopic battle taking place within us every day. The antibodies roam around in our bodies, tirelessly searching for these foreign invaders, ready to attach and destroy. So now that we've got a handle on antibodies and their crucial role in our immune system, let's delve into a special type of antibodies, monoclonal antibodies. So, what exactly are monoclonal antibodies? Well, to put it simply, monoclonal antibodies, often abbreviated as MABs, are artificially produced antibodies that originate from a single clone of cells. This is achieved by a fascinating process where B lymphocytes, which are the body's natural antibody producers, are fused with myeloma cells in a laboratory setting. But why myeloma cells, you may ask? The answer lies in their unique properties. Myeloma cells are a type of cancer cell that can replicate indefinitely, while B lymphocytes have the ability to produce antibodies. When fused together, they give rise to what we call a hybridoma, a cell line that is both immortal and capable of producing specific antibodies. Now, onto the monoclonal antibodies themselves. Unlike their naturally occurring counterparts, which can target a variety of antigens, monoclonal antibodies are designed to recognize unique binding sites or epitopes on specific antigens. This precision allows monoclonal antibodies to target a single type of antigen, making them an invaluable tool in the realm of medicine. Another remarkable aspect of monoclonal antibodies is their ability to distinguish between normal and aberrant cells. For example, they can identify receptors or foreign proteins on the surface of cancer cells, allowing for targeted treatment strategies. Just imagine this, a monoclonal antibody produced in a lab circulating through the body on a mission to find and bind to its specific antigen. And once it finds its target, it attaches itself, signaling the immune system to get to work and destroy the invader. So, in essence, monoclonal antibodies are like tailored soldiers of the immune system, engineered to seek out and neutralize specific enemies, making them a powerful weapon against diseases. Now that we know what monoclonal antibodies are and how they are produced, let's look at their applications. Monoclonal antibodies have a wide range of applications, especially in the field of medicine. These lab-produced molecules are specifically designed to attach to unique antigens on cells, enabling them to perform various tasks, from identifying foreign substances to neutralizing them or signaling the immune system to destroy them. One of the most significant applications of monoclonal antibodies is in the treatment of diseases, particularly cancer. You see, these antibodies can be engineered to recognize and bind to specific proteins on the surface of cancer cells. Once attached, they can perform a variety of functions, such as blocking growth signals, thereby inhibiting the cancer cells from multiplying. But there's more. Monoclonal antibodies can also deliver a lethal dose of radiation or chemotherapy directly to the cancer cells. This is achieved by attaching a radioactive particle or a toxic substance to the antibody. Once the antibody finds and binds to the cancer cell, the attached toxic agent is released, destroying the cell. This approach, often referred to as targeted therapy, is designed to minimize harm to healthy cells, leading to fewer side effects compared to traditional chemotherapy. Beyond cancer, monoclonal antibodies play a pivotal role in the treatment of autoimmune diseases, such as rheumatoid arthritis and multiple sclerosis. In these cases, the antibodies are designed to target and block specific proteins that contribute to the disease process, reducing inflammation and slowing disease progression. Moreover, monoclonal antibodies are being explored for their potential in treating infectious diseases, including COVID-19. Certain antibodies can neutralize the virus, preventing it from entering cells and spreading within the body. As we can see, the specificity of monoclonal antibodies makes them powerful tools in disease treatment. Their ability to target specific cells or proteins with such precision opens up a world of possibilities for developing safer, more effective therapies. Truly, the potential applications of monoclonal antibodies are as vast as they are exciting. Let's now summarize what we've learned about monoclonal antibodies. We started with an understanding of antibodies. These are the elements of our immune system, produced by B lymphocytes that seek out and destroy foreign proteins known as antigens. Next, we learned about monoclonal antibodies, which are laboratory-created proteins designed to target specific antigens. These are not naturally occurring, but are produced by fusing B lymphocytes with myeloma cells. This fusion results in what we call a hybridoma, which is an immortalized cell line that secretes the desired antibody-producing elements. We dove deeper into the uniqueness of monoclonal antibodies, understanding that unlike their naturally occurring counterparts, they can recognize unique binding sites or epitopes on specific antigens. This is what sets them apart from polyclonal antibodies. Monoclonal antibodies are derived from a single B-cell clone to target single epitopes, whereas polyclonal antibodies target multiple epitopes. We also explored the applications of these monoclonal antibodies, learning that they are used in the treatment of many diseases, including certain types of cancer. Their specificity allows them to bind to cancerous cells and deliver a cytotoxic agent, such as a radioactive agent, to destroy the cancer cells without harming the healthy ones. So in essence, monoclonal antibodies are highly specialized tools of our immune system, created in the lab, that can target specific antigens in the body. This specificity and the ability to deliver cytotoxic agents directly to disease cells make them a powerful weapon in the treatment of disease. So next time you hear the term monoclonal antibodies, you'll know exactly what it means, how they're made, and how they're used in medicine. Thanks for watching.